discuss about the implementation of all the logic gates using 2:1 multiplexer. So let's discuss what is 2 raised to 1 multiplexer. So 2 raised to 1 multiplexer have two inputs, one select line, one output. Inputs I1, S0, Y. So whenever my select line S is 0, output will be I0. When select line is 1, output will be I1. The equation will become Y equals to S bar I0 plus S I1. By using this equation, I have to implement all the logic gates. So firstly, we will implement first gate, our NOT gate. What basically a NOT gate is? That is an inverter which invert the value. So this is A, Y. So the equation for inverter is Y is equals to A bar. So this equation we have to implement by using this equation. So how we will do this? Firstly, we choose a variable A as a select line. That means S is equals to A. Then we will make the combinations to realize that Y is equals to A bar. My select line will be A, Y, I0, I1, A0, I1. So suppose if my A is 0, then I1 will be transferred. Okay, so I want that my A bar will be transferred. So that when S is 0, that S bar is transferred to the output. So the A will be A bar I0 plus A I1. So if you put A I0 equals to 1 and I1 equals to 0, so the equation will be A bar dot 1 plus A dot 0. The final equation will be A bar. So by using this, we can implement NOT gate. Okay. So now let's discuss about the AND gate. What is AND gate? Basically, this is a Y equals to A bar. Whenever one of the value is 0, the output will be 0. If both are true, the output will be 1. Okay. So this equation we have to implement by using 2 cross 1 multiplexer. So firstly let's choose a variable that be used as a select line. Suppose B, so S equals to B, come like this, cross 1, select line will be B, I0, I1, this Y. So whenever my B is 1, at that time only B is transferred. Otherwise, if B is 0, that B bar will be transferred at the output. So this I0 will become 0 and I1 become A. So if you write this, when B is 0, that means bar into 0 plus to A. Y becomes A. Similarly for OR gate, the OR gate we know that the equation for the OR gate is A plus B. Okay. Y equals to A plus B. Whenever one of the input will be true, the output will be high. So we have to implement this equation by using 2x1 multiplex. So firstly, we have to choose a variable that will act as a select line. So S will be A, 2x1. S will be A. This will be I0 and I1. I0 and I1 by. So now I0, in case of OR gate, I0 becomes B, I1 become 1. The final equation will be Y is equals to A bar B plus A dot 1. This will be A plus R B. By distributive law, we know that this is modified as plus A bar to A plus B. Okay. So A plus A bar is 1. The final answer will be A plus B. Now let's discuss about the fourth one, is NAND gate. So in case of NAND gate, this is the inverted of AND gate only. The equation will be Y is equals to A dot B whole bar. By Boolean logic, we know that this can be written as A bar plus B bar. This equation we have to implement by using 2:1 multiplexer. So firstly, we will select a variable as a select line. Suppose A is my select line, will become A as a select line. Okay, so this will be Y. This is my I0. This is my I1. So I have to realize this A bar plus B bar. So whenever A is 0, A bar will be transferred. So here I can keep it as 1. So I have realized A bar dot 1 plus. Okay. Then if my A is 1, then A1 will be B bar. Okay. Will be A dot, right. So the equation will become Y is equals to A bar plus A dot B bar. By distributive law, we know that this can be written as A bar plus A to A bar plus B bar. This is 1. So Y becomes A bar plus bar equals to A dot B whole bar. Is NAND gate only. Okay. So now let's move further, which is NOR gate. This is the inverted of OR gate only. The equation for this NOR gate is Y is equals to A plus B whole bar. Okay. Plus whole bar. By using Boolean logic, this can be written as A bar, bar dot. This equation we have to realize from 2:1 multiplexer. So firstly, we will choose one variable that will act as a select line. Suppose A will be my select line. So 2x1, A will be select line. This is A. So this is my Y. So I1. So you know that when select line S is 0, that S bar is transferred. So the A is 0, A bar will be transferred. I have to realize this with the B bar. So I0 will become my bar. This will be 0. The equation will become A bar dot bar plus A dot 0 is bar dot B bar, which is equals to A plus B whole bar. This B bar also we can implement by using 2 cross 1 mux. We have already discussed this NOT gate. Okay. By using this, we can implement this NOT also B bar and this B bar also. Now let's move further. Discuss about XOR gate. We know that what is XOR gate? Whenever both the inputs are different, then output will be high. Y, A, B. Equation of XOR gate is Y, A, XOR can be written as A bar plus A bar. This equation we have to realize by using 2 cross 1 multiplexer. So let's take a variable which is act as a select line. So A will be my select line for this cross 1 mux. Select line will be A. This is my I0, I1, Y, I0, I1, Y. So A, B bar and A bar B. So in which case A bar comes when A is 0. Okay. At I0, what I can do, I0 will be my B. Okay. And in which case the A will be transferred when select line is 1. So when A is 1, this A will be transferred. So the I1 will become B bar. Equation will be A bar dot plus A dot bar, which is XOR gate only. So this B bar, we can implement this by using this mark, the first one. So now let's discuss about XNOR gate. XNOR gate. So XNOR gate is nothing the inverted XOR gate. The equation for the XNOR gate is Y equals to A B A dot B plus A bar B bar. Okay. So this equation we have to realize by using 2 cross 1 multiplexer. So first we will select the select line. Okay, so let's take B is my select line. So B will be my select line. In this case, B bar, when B is 0, B bar will be transferred. So I1. So with B bar, there is one variable called bar. When my select line is 1, this variable will be transferred, that is A. From bar plus A is XNOR. So let's conclude this. We have discussed all the logic implementation by using 2 cross 1 mux. So instead of memorizing all the circuit, remember this simple trick. Select one variable as a S. So put the value s equals to 0 or s equals to 1 in the function which gives I0 and I1, and then connect accordingly whatever the logic gate you have to make. Okay. If you found this video helpful, like the video, subscribe the channel and support the journey. See you in the next lecture. Thank you.